Welcome to yet another video session. In this video session, we will discuss about computational thinking. So today we will discuss about what is computational thinking, what are the components of computational thinking, how we can use computational thinking for problem solving, and what is the importance of computational thinking in our daily life. Okay, so without wasting time, let's get started. Computers can be used to help us solve problems. However, before a problem can be tackled, the problem itself and the ways in which it can be solved need to be understood. When we write a program, we are writing a set of instructions to solve a problem involving data processing. These instructions have to be executed by the computer to solve the problem. If the instructions are correct and given in a correct sequence, then the problem will be solved properly by the computer. And if the instructions are incorrect or in a wrong sequence, then the problem will not be solved correctly and will not be solved at all. Therefore, writing correct instructions in correct sequence is extremely important before we write a program. We should be thoroughly clear in the steps for solving the problem. We should be thoroughly clear in our mind about the steps for solving the problem. If we start writing the problem without knowing how to solve the problem, then we can never write the correct program. This leads us to the concept of computational thinking. Computational thinking can be defined as the process involved in formulating a problem and expressing its solution in such a way that the computer, human or machine, can effectively carry out. So to write any program, first we have to think computationally about the problem and its solution, and then we have to write the program in a programming language. Every day in our day-to-day life, in all the aspects of our life, we perform computational thinking. Think of all the actions and the decisions that we take in our life. All the situations in our life require thought process for finding the best solution, and thus computational thinking becomes a crucial aspect. So let us see what do you mean by computational thinking. What is computational thinking? Computational thinking allows us to take a complex problem, understand what the problem is, and develop best solutions. We can then present these solutions in a way that a computer or a human or both can understand. The process of planning and reaching the goals involves computational thinking of some kind. Computational thinking involves taking the complex problem and breaking it down into a series of small, more manageable problems. That is known as decomposition. Each of these smaller problems can then be looked at individually, considering how similar problems have been solved previously. That is known as pattern recognition, and focusing on the important details while ignoring the irrelevant information. That is known as abstraction. Next, simple steps or rules to solve each of the smaller problems can be designed. That is known as algorithm. So now let us see the different components of computational thinking. Computational thinking is a technique used to solve problems logically and consists of 4 key components or pillars, which are described as follows. So first is decomposition, second is pattern recognition, third abstraction, and the fourth one is algorithm. So we will discuss them one by one. Decomposition. Decomposition is the process of breaking down a complex problem or system into smaller, more easily solved parts. These smaller problems can be solved one after another until the bigger complex problem is solved. This stage involves breaking down the problem into smaller components so that they can be tackled easily. The more you break down a problem, the easier it is to solve. Some of the real life examples of decomposition process are when we taste an unfamiliar dish and identify several ingredients based on the flavor, we are decomposing the dish into its individual ingredients. Next example is when we give some directions to our house, we are decomposing the process of getting from one place to another. Next example is when we break a course project into several steps, we are decomposing the task into small, more manageable subtasks. In maths, we can decompose a number such as 256.37 as follows. So we can break down any problem into simple tasks to solve any mathematical problem. So for example, the equation to find out the roots of a quadratic equation. X is equal to minus b plus minus under root of b square minus 4ac divided by 2a. So this is the formula to calculate the roots of quadratic equation. So now this can be decomposed easily. The steps to solve a problem. We can often recognize patterns, and by giving a list of steps, we are one step closer to creating an algorithm. Next topic is pattern recognition. Pattern recognition is the next process in succession that helps in identifying patterns or trends within a problem. Once you have decomposed a complex problem into simpler problems, the next step is to look into the similarities they share. We look for the patterns when we play games to decide when to do certain things. Based on the experience, we develop shortcuts for mapping problems, characteristics to solution. So what do you mean by patterns? What are patterns? So take the example of any animal. All cats share common characteristics. Among other things, they have eyes, tails and fur. They also like to eat fish and make meowing sounds. Because we know that all cats have eyes, tails and fur, we can make a good attempt at drawing a cat simply by including these common characteristics. Once we know how to describe one cat, we can describe others by simply following this pattern. One cat may have green eyes, a long tail and black fur. Another cat can have yellow eyes, a short tail and script fur. We all experience pattern recognition in everyday life. For example, drivers look for patterns in traffic to decide which and where to switch lanes. Next is people look for patterns in stock prices to decide when to buy and sell. Scientists look for patterns in data to derive theories and models. We look for patterns and learn from them to avoid repeating the same mistake. Patterns are shared characteristics that occur in each individual problem. What similarities do you observe? Finding these similarities in small problems can help us to solve complex problems more efficiently. Next is abstraction. Abstraction refers to focusing on the important information only, ignoring irrelevant detail. To reach a solution, we need to ignore unnecessary characteristics in order to focus on those what we do. It helps us to identify specific similarities and differences among similar problems to work towards a solution. So what is important information that we need to focus on? In abstraction, the focus is mainly on the general characteristics that is common to each element instead of specific details. Common example of abstraction can be a world map is an abstraction of the earth in terms of longitude and latitude, help us describe the location and geography of a place. A sign or logo in a store, example Walmart, is an abstraction of the items available in that store. When we write a book report, we summarize and discuss only the theme or the key aspects of the book. So this is known as abstraction. Once you have the general characteristics, you can create a model of the problem. A model being the general idea of the problem we are trying to solve. Once we have a model, we can design an algorithm. Next is algorithm. Now we have broken down the big problem into smaller, easily manageable problems. You have identified similarities between these problems. We have focused on relevant details and left behind anything irrelevant. Now it is a time to develop step-by-step instruction to solve each of these small problems or the rules to follow when solving the problem. These simple steps or rules are used to program a computer to help to solve a complex problem in the best possible way. They are called algorithms. So we can say an algorithm is a plan, a set of step-by-step instructions used to solve a problem. Now let us see how we can integrate computational thinking with academics. Computational thinking is extremely important not only while working with computers but in other applications also. Computational thinking even works well in classroom teaching as well. The implementation of computational thinking in a classroom can be compared with various important subjects. Subject area application, literature. Break down the analysis of a poem into analysis of meter, rhyme, imaginary, structure, tone, diction and meaning. Economics. Find cycle patterns in the rise and fall in the country's economy. Arts. Write a recipe for others to use. Mathematics. Figure out the rules for factoring second order polynomials. Chemistry. In chemistry, determine the rules for chemical bonding and interactions. The area in which we can apply computational thinking can be any subject area or topic, even the subject area or topic you teach. These way of thinking can be used anytime you want to develop a process or algorithm to solve a problem. I hope you find this video useful. If you have any suggestion or queries, then you can ask in the comment box. For more interesting videos like this, please like, share and subscribe to this channel.